Hello and welcome to episode 7 of Astromagnet. I'm Arush Ramadurai,
And I'm Ishan Chakrabarti.
and today we're going to be talking to Martina Arndt, professor of physics at Bridgewater State University.
Welcome to the professor, Dr. Arndt.
Thank
Welcome to
you.
the podcast, Dr. Arndt.
Thank you very much for having me.
When did you first get interested in astronomy? Why are you interested in astronomy?
Well, I think I can say that as a young child, I was always interested in astronomy. I think most kids are. We look up and wonder what it is we see in the sky, and we start to think about the idea that light that we're getting from stars might be millions of years old, and the fact that we're looking back in time. And so I would say, I don't have a specific date, but I certainly know it was when I was young, and I really enjoyed watching Carl Sagan's Cosmos. I know we talked about that when I gave my talk to your club. And I think that really solidified it when I was about 11 years old. And what really interested me was just wondering what was beyond where we are now in the end. So it was just sort of a sense of wonder. And it's also beautiful, to be outside looking up at the night sky. And I always thought about being a nighttime astronomer, which is ironic since, as you know, I ended up being a solar physicist.
So, what's your main focus of research that you do now?
So I have two main things that I focus on at this point. The solar physics, right, with the eclipses is certainly the primary one. But now that I've been working with students for 20 years at Bridgewater State, right, we do a lot of exoplanet work. And so I would say that exoplanets are a secondary but minor compared to the solar physics research.
So can you talk about your experiences studying solar eclipse?
Sure.
Like what have you found and why is it important for us to study them?
Sure. That's a big question. So let me first start off with, my experience of studying the eclipses. When I was a graduate student, what I studied was a solar flare on the sun. And it was my collaborator who I met straight out of college, Dr. Shadia Habal, who invited me to join her on an eclipse expedition back in the 1900s. I can't remember what year. I think it was 1996. And I went with her because she's my science mentor, and that's when I got the bug. And so anytime she asked me after that, almost every single trip I've been on, I've actually gone on those eclipse expeditions. We can talk more later about what that's like. But one of the main reasons why studying solar eclipses is so important is it's the one time we can have the sun covered just the perfect amount to be able to get data from close to the solar surface. The solar surface is about, 5,800 Kelvin. And then when you move away from the solar surface, it gets much, much hotter by several orders of magnitude. And so it's very curious as to why that happens. And so the way we try to study that is to come up with theories, right? And anytime you have a theory, you need to test it. And the best way to test it is with actual data. And then you fine tune your theories and so forth. And so that's why solar eclipses are really, really important. And they are best observed from the ground. Well, there have some people have observed eclipses from, balloons or from airplane trips and so forth. But basically close to the Earth, sending a satellite up into space, you don't get the same effect of having the moon covering the sun as well as you do on Earth, although people are working on that. And so ultimately, the two main things I think we're trying to study with solar eclipses is why the temperature goes up when you leave the solar surface, and also the particles that are leaving the sun. They kind of come in two flavors, the fast and the slow, and we don't know why. And, we have good ideas and so forth, but again, you need data to test those theories.
So can you talk a little bit about the trajectory of your career? So, what kind of education did you receive that prepared you for it?
Sure. There's kind of education that happens inside the class, and there's education that happens outside of the classroom, right? And so in many ways, my career is just based on work that I've done, opportunities that have come up, some luck involved, and some decisions that were basically made for me. So if we start off at high school, which is the stage I know you two are at right now, I grew up in Newton. I went to Newton North High School, and I always loved math. And so I knew that was something that I wanted to do. And then I only applied to one college, unlike you two who've spoken about applying to multiple ones, right? I only applied to one college, and I applied to Wellesley College, and fortunately, and I think I did early decision as well, right? And so they accepted me, which is, again, I was prepared, but also a little bit of luck, right? Because if they hadn't accepted me, I don't know what I would have done. I would have probably, had to start applying other places. And then there in college, I realized I didn't want to be a pure math major. And so I took a lot of, in a liberal arts education, you take general education courses that encourage you to explore different disciplines. I took economics and I thought that was really cool. And I thought I'd major in that for a while. And then sociology, same thing. Art, well, I'm a creative person. I'm not talented enough to be able to draw or paint. And so I needed to take a lab science. So I took one that I thought would be fun. And based on what I've said already, I said, well, astronomy sounds fun. And I took it and I loved it. And it was hard. It wasn't easy. And then I had a faculty member who really encouraged me to continue taking more classes. And then I ended up majoring in astronomy. Then when I graduated, I was very burnt out. I really had no energy left to go back to school. And I was fortunate enough to apply for one job and get this one job. And this was at the Harvard Smithsonian Center for Astrophysics, working with Dr. Shadia Habal on solar physics. And I worked with her for 2 years as a research assistant. And, I had the opportunity to really work on a project and first author a paper and be around other scientists and sort of learn from them about what being a scientist would be like as a professional career, and realizing that they were human in addition to being really smart. And that was a little less intimidating. So after 2 years, I applied to a bunch of graduate schools. This time I said, I'm going to apply to a whole bunch, right? But I was only accepted at one, and that was at the University of New Hampshire. And so you'll notice that a lot of decisions were made for me along the way. One undergraduate institution, one job offer, one graduate school that accepted me. And UNH was a great place for me. I had a lot of support through my 7 years there. And when I graduated from there, I applied for a few jobs and I was only offered one, which was Bridgewater State. And it's been a fabulous, fabulous place, right? Now, the stuff that happens outside the classroom is often the research. It's also the struggles that we go through. It's the things that we do for fun that make us interesting. And I like to do scrapbooking, and I like to quilt, and I like to, cross stitch and knit and those sorts of things. And I think believe it or not, I think those creative endeavors help me in my career with being a creative problem solver, thinking about problems in different ways. So it's not just the nuts and bolts of what school you go to and who you work with. It's a combination of those things, but also other things that make you a rich and whole person. So let me see, did I answer your question, right? You asked me what about the trajectory that I had and what kind of education. I think I got to those two. Is there anything else you want me to add?
Well, what were some of the favorite research experiences that you had, like as an undergraduate, a graduate student?
Okay. Yeah, so if you've got high school students listening to this podcast, I really encourage all of them to consider doing research when they're undergraduates. And that sounds a little daunting because you don't know necessarily what a research project is. But if you find a faculty member, like I've had a couple who do really interesting work. Like one of them was Dr. Richard French at Wellesley, and he studied Saturn and Saturn's rings. And he talked about how, when Saturn passes in front of a star, the rings act like the pickets in a picket fence with a flashlight going by, and you could see dips in intensity every time the light from the star would hit a ring. And you could learn a lot about that ring, like how wide it was and how dense it was, and maybe even what it was made out of. And I thought that was really cool. And so in the end, he invited me to join him. I might have even asked, I don't know, but to do a small research project on Saturn's rings. And here's the ironic part. I thought I was killing it. And then he sat me down at one point and he said, you analyzed this entire chunk of data wrong, and let's talk about why. And it was mortifying because I thought I had to get it right on the first try. But you don't in research. In most problems, you don't get it right the first time you try it. And so while it was sort of a scary experience to do something wrong, it's also one of the more formative experiences I had, and learning experiences. So in that way, it's one of my favorite ones, right? But I would have to say every single eclipse after that, right, was a great research experience. You know, my colleague, Dr. Habal, she works in Hawaii now, and so I get to travel and so forth. As a graduate student, my thesis project was what I lived and breathed for many, many years. So in many ways, that project was a personal endeavor for me. And so in that, it's favorite for me in that way. So bottom line is you need to do research at some point because it's a real life problem. It's not a textbook. It's not something you can Google. It's not someone's thought about before. And it's kind of exciting and scary at the same time, right? Now you asked about classes. Oh, I loved all my math classes. And certainly my astronomy ones. That doesn't mean to say I didn't get frustrated a lot, but it was really fun to be in a room with people who were interested in the same thing I was. And I look at math problems as a challenge, and I like to solve them, you know, like little puzzles. And then you know what the answer is. It's kind of exciting.
So could you discuss a little more about traveling around the world to see solar eclipses? What were some of your favorites?
Sure. So I get asked that a lot. I think I've been to 12 eclipses. And my favorite thing about going to any of them is that I go to parts of the world that I would never think to go, right? Like going to Mongolia or the Marshall Islands or to Nebraska, right? I would have no other reason to go to Nebraska other than, you know, an expedition like this. So what I love about it is that I get to see other parts of the world. I get to meet different people. I get to realize that the world is so much bigger than I am. And that's one of the reasons why I thought it was so important to bring my family along with me, because it's important to see, especially when you're young, that the world is more than just your group of friends, just your high school, more than your town. It's more than the United States. It's a higher global community. I think that's really, really important part of that. My favorites, my least favorites are the ones where I'm hot. I really don't like being hot. Okay. So if it's like someplace where it was summer at that time and it was the heat and we're inside tents and we're working on instruments, I really dislike being hot. That being said, I mean, I loved being up in the Arctic Circle because you can bundle up and, you know, um, my favorite eclipses also are the ones that tend to be the most successful. In the end, sometimes there's clouds and we don't get data, and that's frustrating, but it's just a reality. Sometimes things don't work. So I don't have a specific one, but I know that my least favorite ones are the ones where I'm hot.
What is your favorite part of your job?
So right now I'm an associate dean, and so I've only been in this job for a year and a half. So let me step back and talk about my favorite part about being a faculty member, because that's really what I've done most of my life. And my favorite part of my job in that case is working with students and trying to help them learn about a subject that I really, really enjoy. I do remember when I was being interviewed for the position, they asked me what my least favorite thing about teaching was. And I think they fully expected me to say grading, but that's not the thing that popped into my head. What popped into my head is that I cannot convince every single person in my classroom that astronomy or physics is the ultimate in what you need to do. Like I want to convert everybody to become like a physicist or an astronomer, but I'm never successful in getting 100%, and that's okay. But that's my least favorite part about, you know, teaching. But I really, really enjoy helping other people learn, helping them find something that they enjoy and they love and they feel passionate about, supporting them while they take these risks and challenges and jumps, like applying to colleges or trying a new project, or, you know, it's kind of a privilege to be part of that journey. I don't want to make it easy for everybody, because I mean, I'd like to make it comfortable. I can't solve everybody's problems, but I'd like to be part of the journey as people make their way into their future. You know what I mean?
So could you talk about a little more about your exoplanet research as well? I thought
Sure,
that was pretty interesting.
sure. Yeah. So, you know, exoplanets really briefly are planets that are orbiting other stars in our galaxy is the easiest really to look for. At Bridgewater, what we can do is we can look at a star and measure its intensity. And much like Saturn's rings, when something passes in front of the star, right, the light intensity dips down. And how much it dips and how long it dips for tells you something about the comparison between the star and the object that's going around it. You can learn a lot about these planets. There's a lot of satellites up in space right now that are trying to detect planets around other stars, and they're much, much more sensitive because they have no atmosphere in the way. They have really, really good optics. But there are so many candidates that they identify as possible exoplanets that they can't spend all of their time saying, ooh, look at that one over there. Let's keep spending our time looking at that one, when in fact they should be trying to identify other possible candidates. So TESS and Kepler and so forth, they spend a lot of time saying, okay, these 3,000 stars are possible hosts for exoplanets. And then people like us at Bridgewater and other observatories then spend our time looking at maybe candidate number 22, right? And we can spend time nights observing it and trying to get a sense for, you know, how long the dip is, how deep the dip is, and so forth. And so the kind of work we do is consider confirming exoplanets. And again, we're not going to confirm a single exoplanet. We will be joining hosts of other people who are making observations of star number 22, right, to see if it has a possible candidate, like an actual exoplanet going around it. And so it's wonderful for undergraduates because they can spend a semester making observations, looking at the data, trying to make some guesses and so forth on, you know, whether or not it's an actual exoplanet or not. And what we're trying to do at Bridgewater is use spectroscopy as the next step to help us identify if it's two stars going around each other or a star and a planet orbiting each other. And it's a very long process trying to get that to work because, you know, students are all taking classes. Many of our students work full time. And so they can spend, you know, maybe 5 hours a week at the observatory, as opposed to like graduate students whose lives are, you know, dedicated, glued to the telescope. Yeah, so that's sort of what we're doing with exoplanets at Bridgewater.
What career challenges have you run into and how did you navigate them?
You know, it's funny. Maybe I just look at challenges as, well, this is what I'm facing and off I go. So I don't always think of them as challenges. But let me step back and think. You know, not having a choice of where to go to college, not having a choice of what job to take ultimately, right? Because I only had one offer in each one of these cases, was like, how I navigated them was like, okay, this is what I've got and I'm going to go and I'm going to make the best of it. I try very hard to make the best of every situation, take the most out of it. I'm an optimistic person by nature. So I say, okay, here we are. And, you know, what can we do with it? And I think that ultimately helps me be successful in what I do. Never once do I feel like, geez, you know, Wellesley was second choice. That never was the feeling that I had, right? It was almost like a gift. This is what's given to you, you know, and make the best of it, right? Other challenges, I would say sometimes as a woman, it's very hard in the field of physics. To be a minoritized person at all in any field or room can be challenging. But I can speak to what it feels like to be a woman in a room. And, you know, more than once I've been told that you only got into UNH because you're a woman. And I would say, well, that's part of the reason why I got in, because guess what? Having a diverse group of people trying to solve a problem makes the solution usually a lot better, right? And there's very few women in this room at the moment. But also, I mean, I had a first author on a publication and so forth, but that's not what they saw. They instead assumed that I was not qualified to do what I was doing. And so that is a challenge. Navigating things like, I think the term is still being used as the microaggressions that, you know, if I have an idea or if I speak up and people nod in agreement, but then someone else will bring it up and they'll think it's the best thing they've ever heard, you know, that can be very frustrating. But, you know, I'm old enough now, I'm established enough now that I'll tend to call people out and, you know, say, I just said that, you know, that sort of thing. So I think the challenges can be really small, a small scale like that, or they can be the bigger ones like, you know, now you've gotten to graduate school for physics and you've had 3 physics classes. What are you going to do, right? So it's kind of what are the challenges? Writing grants is hard, trying to get money for things and and not always being successful, but that's also par for the course. But you don't give up. So that's how I deal with it. You just don't give up. You know, make a change, make an iteration, and try again. And if that doesn't work, then you find something else.
So you mentioned how important it is for undergrads to do research, but is there
Yeah.
any other advice you have for students aspiring for an astronomy career?
The- I get asked that often, and I think over time I fine-tuned my answer to be very generic, and it's to be an interesting person. Um, and by that I mean, yes, do the coursework you need to do, but if you only sit there and do your coursework and don't have something that you're passionate about. Like if you're just ticking things off to say, I'm doing this, I'm doing this, like following a recipe. You can't just follow a recipe to become, I don't know, an astronaut or a PhD in physics. You have to, at some point, differentiate yourself from this little checklist to say, who are you as a human being? And I think getting to know yourself a bit and saying, this is what I'm passionate about. Like, who would think that a physicist would be, loving to make quilts? That's not on the typical checklist, right? But what it does is says that I'm a creative person, and that then creates, a more well-rounded part of me. And I know as high school students, you are all thinking about the checklist, and you're all thinking about the school that you want to get to, and at some point you'll hopefully reach the stage where you say, instead of saying, I'm doing this so I can get into school, you can say, this is what I want and what school can help me, right? So it becomes more about you instead of about them. And that comes later in life because, you got to get through college. Certainly you have to do that. And no matter what school you end up going to, just try and take advantage of opportunities that you have to try things, study abroad, join a squirrel watching club, go, do some research with somebody, just do things that make you a whole person. And so, there's, yes, being good in math is very important, for example. So, and what does that mean to be very good at math? Do you need to know how to do, I don't know, really abstract algebra to be able to do, you know, um, some of the work that I do? No. So you don't have to push it so far to the limits, but just try and stay on top of those things. So if you were looking for a checklist, I think those checklists, right? To do the sciences, do the math. I think knowing a foreign language is really important because it trains your brain to see things differently. Be a musician, do things that make you whole as a person and that you feel passionate about. To my mother's credit, when I told her I wanted to major in astronomy, she didn't say, what are you going to do with that? Right? Because that's not a standard major, but it was something that I was really, really passionate about. And because of that, it helped me get through to those other stages, if that makes sense.
Um,
Is it all right if interested high school students contacted you for advice and
Of
guidance?
course. Of course it is. Of course it is. And I want to say one other thing too, is that another thing that will help you be successful in becoming a scientist or reaching your goals in these sorts of fields is you're never alone. So make sure that you have a group of colleagues that you can work with, classmates, friends. And it doesn't have to be another physicist. It could be an engineer, it can be an artist. I mean, one of the strengths of the eclipse groups is that I go on is it's a group of people made up of scientists, engineers, artists, teachers, students, computer science folks. It's like a hodgepodge of people. And if you face any problem, someone's going to be able to help you solve it, right? So in many ways, I think of high school as being kind of isolating in a way because you always do a lot of stuff on your own. But in graduate school was the first time where I had a large group of people where, like, if we wanted to work on a problem set, maybe you do this in high school, I didn't. We'd get up and we'd just stay up for hours and we'd have we had chalkboards at the time, chalkboards, and we'd have coffee and we'd have snacks and we'd try and tackle problems together on the board. And there's no way I could have gotten through graduate school without my friends and without my classmates. So that's another way to be successful is, make sure you work with people and you welcome people into your group and you try to have like a larger perspective from other people in the room. So back to I wanted to add that on to my last answer, but yes, I'm more than happy to have students reach out to me. Absolutely.
that's great.
Yeah.
So thank you so much for your time. So that was Dr. Martina Arndt, and to learn more about her field, check out our website for additional resources.
Thank you, and we'll be back with another episode.